Good morning, students. Today we'll try to find the general solution from the given differential equation. I am talking about the chapter differential equation from maths from class 12th. So let us try to understand how to find the general solution from the given differential equation. That is, we'll try to solve the exercise 9.4. Let's begin with the chapter we all know, that is the differential equation. Now we'll try to solve to find the general solution from the given differential equation. Let us try to solve. Let us try to find. Okay, so we'll begin with try to solve the exercise, that is 9.4. Okay, so let us begin with the first question I have. Okay, so the question we have to solve, that is what they have given is dy by dx upon 1 minus cos x upon 1 plus cos x. We have the question dy upon dx is equal to 1 minus cos x upon 1 plus cos x. Let me confirm first. The question is 1 minus cos x upon 1 plus cos x. Okay, so here we'll try to solve the question. We have 1 minus cos x upon 1 plus cos x dx like this. So now we'll try to solve. That is, what we can do, we can use the formula for cos 2x. We know that we have two formulas for cos 2x which we use most commonly, that is 2 cos square x minus 1 and 1 minus 2 sin square x. Okay, so now if I take that side, so I got, that is 2 sin square x is equal to 1 minus cos 2x. If I divide by 2, I got here 1 minus cos x. So here I will try to put 2 sin square x by 2 upon, here is 1 minus cos x, 1 plus cos x in the denominator. So what we can do here, we try to use this identity. So if I take this, I will got 2 cos square x by 2. Okay, so now I got tan square x by 2. What I can do, we know the formula for that is 1 plus tan square x is equal to sec square x. So tan square x will be sec square x minus 1. So here sec square x minus 1. Okay, so now we have this. We all know the integration of sec square x by 2 will be tan x by 2, and here we differentiate with there, so we can find this. Now we know the integration of sec square x is equal to tan x minus x. Here we have, so we have plus c. So that is why I try to find the equation, that we try to find the general solution from the given differential equation. So that is how we try to solve the question. Now let us try to solve the another one. Next question I have. Okay, so the next question will try to put first. Okay, by 2, 1 by 2 is also there. So what we can take 2 tan x by 2 minus x plus c. Okay, so it's how this is the general solution for the given differential equation. Now let us try to solve the next question. Okay, this is the first question I have solved. Now let us try to solve the next question. Now we have given the next question, that is we have dy upon dx. We have dy upon dx. We have second question, dy upon dx is equal to 4 minus y square. Okay, here value of y is minus 2, 2, 2. They have given this. So now let us try to solve. How we can solve? dy upon 4 minus y square under root is equal to dx. Okay, so what we can do here? We know that it will become this. So I can write like this: 2 square minus y square under root is equal to x we have. Now x plus c. So now this we need to solve this. That is, we need to apply the formula here of under root upon 1 upon under root a square minus x square. So that formula will apply, and that the formula is, we have sine inverse, that is, we have the formula, that is sine inverse x upon a minus x, okay, is equal to c. Okay, so that is how, that is what they have given the differential equation, and we need to find the general solution. Okay, so that is how we are able to solve. Let us try to solve the next question here. Okay, so now we have the next question here. The next question is, that is, we have dy upon dx plus y is equal to 1. Y is not equal to 1. Okay, the dy upon dx plus y is equal to 1. So now what we can do? Dy upon dx 1 minus y. Okay, dy upon dx is equal to 1 minus y. Now dy upon 1 minus y is equal to dx. So now what I can write here, 1 square minus root y whole square is equal to x plus c. Okay, so now to integrate a square minus x square, so here I will try to solve the, try to put the value here, so that we'll try to solve like this. Or what we can do, instead of writing this, we can take common here. Okay, so after taking common, now I got log y minus 1 is minus is equal to x plus c. So what we can do here, x plus log y minus 1 plus c. Okay, so this is the required general solution of the given differential equation. Let us try to solve more. Okay, we have just solved only 3 questions now. Now we'll try to solve 4th one. Now what the question says, let us see. Now we have the 4th question here. The question is, that is, we have, this is the question we have. 4th question I have, that is sec square x tan y dx plus sec square y tan x dy is equal to 0. Sec square x tan y dx plus sec square y tan x dy is equal to 0. So this is the, we have this differential equation. Now let us try. Okay, now what we will do, we will try to find its general solution. Now what we will do, divide this by tan x tan y. So after dividing, we got tan x plus, we have tan x tan y. Okay, so I have this. What we will do here, we will try to put the value here. So okay, so we will write divide by 10 x 10 y. So we got this. So now we know that integration of f dash x upon fx dx is equal to log of fx. This is the formula I have, because we know that differentiation of tan x will be sec square x and differentiation of tan y will be sec square y. So we got this, that is integration of f dash x upon fx dx is equal to log of fx. Now log of fx is there, so what we will do here, we'll write log of 10x plus log of 10y, and y is equal to c, because here they have given the 0 is equal to c here, so I can write log of c. So we'll take both sides log now, so that I can write like this, log of 10x 10y is equal to log of c. So I got here, that is 10x 10y is equal to c. So now 10x 10y is equal to plus minus c, because we know if I take t is equal to a, where a is greater than 0, so t will be plus minus. So I've used this. So finally I got the differential equation, that is why I got the solution, the general solution of the given differential equation. Now let us try to solve the next question. Okay, now let us try to solve the fifth question. We have just solved, this is a method we can say to find the general solution of the given differential equation. Now we'll try to solve the fifth question now. Okay, so we have the fifth question here. What they have given, e raised power x plus e raised power minus x dy is equal to, no, they have given a negative sign, no, e raised power x minus e raised power minus x dx is equal to 0. Okay, so they have given that such equation. Here what we can do, take this on the RHS. So ex plus e raised power minus x dy is equal to e raised power x minus e raised power minus x dx. So now what I can write, dy is equal to e raised power x minus e raised power minus x upon e raised power x plus e raised power minus x dx. So now we need to integrate this. So what we can do here, it will be a very similar situation here. Y is equal to, what we can do here is we can just differentiate this. So I will get this much. So that is I have, we can say that is if f dash x upon fx dx they have given. So here we can write log of fx. That is what we can do here, because they have given, if I take its t and differentiate it, so I will get this. Okay, so now I can directly put here, therefore y is equal to log of fx, that is e raised power x minus e raised power minus x plus c. Okay, so I got this. Now we'll see. Now we have this. Now let us try to solve one more questions. We have just solved only 5 questions. Now what we have in the sixth question, let us see. That is the sixth question we have, that is dy upon dx is equal to 1 plus x square 1 plus y square. So now what we can do here, in a very simple way, if we need to integrate, what we will do, dy upon 1 plus y square is equal to 1 plus x square dx. So now we have this 1 plus x square, a square plus x square. So now what we will do, we'll try to solve this x square plus a square we have. So here we'll apply the formula, and here also we will apply the formula. We can integrate like this: x plus x cube by 3 plus c, and here we'll now see the what we have the formula. Okay, so now using the formula I will write tan inverse y is equal to this. So this is the required solution, tunnel solution for the given differential equation. We know the formula for that, that is dy upon x square plus a square, and integrate we will find this, that is tan inverse x upon a. So x is y and a is 1. So we'll have this solution. Now let us try to solve the seventh numerical. We have just solved 6 numericals. Now we'll try to solve the seventh numerical we have. And the seventh numerical I have, that is y log y dx minus x dy is equal to 0. So now what we can do here is y log y dx is equal to x dy. So now we have this. What we can do here is, in a very easy way, dx upon x, okay, is equal to, we have dy upon y log y, we have this. Okay, 1 upon x we know log x is equal to, now I will say that if I put log y is equal to t, if I say log y is equal to t, so we have 1 upon y dy is equal to dt. So dt upon log y is equal to t. So I have log x is equal to 1 upon t. So we have 1 upon t. So now we'll try to integrate, that is log t. We have log t plus c. And what is log t? We have log of y plus c. Okay, so that is how we try to solve the numerical. Now let us try to solve the next question, that is the eighth question now. Okay, now let us try to solve the eighth numerical we have. We have just solved the 7 numericals. Now 8 I have x is power 5 dy upon dx is equal to minus y raised power 5. Okay, so now how we can solve, let us see. If I take x is power 5 dy is equal to minus y raised to power 5 dx. So now we can write here dy upon y raised to power 5. Okay, I take minus y here is equal to dx upon x raised to power 5. Okay, so now if I say this, what will happen? Minus y minus 4 plus 1 minus 3 plus c is equal to minus 5 plus minus 4 upon minus 4 plus c. So I got here, that is 3, that is I got y minus 3 upon 3 plus c is equal to minus 1 upon 4 x is for minus 4 plus c. Okay, so that is how we easily find the solution of the given tunnel, of the given differential equation. Now let us try to solve the next one. Now we can easily say 1 upon 4 x minus 4, okay, plus y minus 4 upon 4 plus c. Okay, so that is how we solve the to find the differential to find the general solution of the differential equation. Now let us try to solve another question. We have just solved only 8 numericals. Now let us try to solve the ninth numerical. Okay, let us see how we able to find the general solution for the given differential equation. Okay, so now let us try to solve this. We have ninth question, that is dy upon dx is equal to sine inverse x. So now how we can solve? Let us try to see dy is equal to sine inverse x dx. Now we'll try to solve it by parts, like we'll solve sine inverse x into 1 dx. So we have this, that is sine inverse x. Now what we can do here, put the sine inverse x as first function and it will take the second function. Okay, sine inverse x integration of dx minus integration of first differentiation of first function sine inverse x into integration of dx. Okay, so now we'll try to solve it. We'll got sine inverse x into x minus, now if I integrate this, so I got 1 upon 1 minus x square under root into x, we got dx. So now what we can do here, x sine inverse x. So now what we can do here, let this plus here multiply 2x upon 1 minus x square under root dx. Now if I put 1 minus x square is equal to t, so that minus 2x dx is equal to dt. So I have x sine inverse x. So I have dt upon root t. Okay, so now I have this x sine inverse x plus, I got x sine inverse x plus root t. So we'll have minus half, so it will have root t upon half plus c. So now I can put here x sine inverse x plus 2 root t. What is t? 1 minus x square plus c. So that is how we able to find the general solution of the given differential equation. Now let us try to solve the 10th numerical. Okay, so now just we have solved 9 questions. Now we'll solve the 10th question from the exercise. So we have just solved only 9 questions. So now I have the 10th question in my hand, that is ex tan y dx plus 1 minus ex sec square y dy is equal to 0. Okay, now let us see how we can solve. If I take that on RHS, that thing on the RHS, I got 1 minus ex minus sec square y dy. So now what we can do here, we can take this and that here. So I got 1 minus x, sorry, that is 1 minus ex dx. Now here I got minus sec square y upon tan y dy. That is how we try to solve it. Now what we will do, we'll try to integrate them. Okay, so I can take this negative sign here. So now what I can do, if I take this negative sign inside, so that if I put 1 minus ex is equal to t, so I got minus ex dx is equal to dt. So dt upon t is equal to, now we know we have the differentiation of tan y will be sec square y. So here I can write directly log of tan y plus c, and here 1 upon t, that is log t. Log t is equal to log of tan y plus c. Now t is what? We have log of 1 minus e raised to power x is equal to log of tan y plus c. Okay, I got this. Here what we can do, I can take log of tan y minus log of 1 minus ex plus c. So we can write or log of tan y upon 1 minus ex. We all know log x minus log y, log x upon y, and I've taken this side, so we have c here. So now we can take log of c, so we will have tan y upon 1 minus ex is equal to c plus minus c. Okay, so that is how we try to solve such kind of questions. Now let us try to find another solution for a given differential equation. Now I have the question in my hand, that is 10 questions we have done. Now we'll try to solve the 11th question now. Okay, let us see how we can do it. Now let us try to solve the 11th question. Now we have the question, that is x cube plus x square plus x plus 1. We have dy upon dx is equal to 2x square plus x. This is the given differential equation. We need to find the general solution, plus also they have given some condition, that is y is equal to 1 and x is equal to 0. Okay, when x is equal to 0, okay, y is equal to 1. Okay, so now let us try to solve such kind of questions now. So now what we can do here is, in a very simple way, we'll take dy is equal to 2x square plus x upon x cube plus x square plus x plus 1. We have dx. Okay, so now let us try to solve this. How we can solve? Let us see. You can take x square common from here, x plus 1 and 1 from here. Okay, so now what I got here, 2x square plus x upon x square plus 1 and x plus 1 dx. So now what we can do here, 2x square plus x is equal to a upon x plus 1 plus bx plus c upon x square plus 1. Okay, now we'll try to solve this. How we can solve? Now we can take a as x square plus 1 plus b x plus c. Okay, so we have this 2x square plus x. Now we need to compare on both sides. Here I am using the method of partial fraction to integrate this. So now we have a, okay, we have a, okay, wait, we need to complete this, ax square plus bx square plus bx plus cx plus c. So now I can compare a plus b is equal to 2. Then we have b plus c is equal to 1. B plus c is equal to 1, and we have c is equal to 0. Okay, we have c is equal to 0. No. We have a plus c is equal to 0. C is equal to 1. A plus b is equal to 2. So that is how. So now we have, if I put the value here, that is, okay, what I can do here is just try to solve. Okay, if I put here, now we have three equations. Huh? So now we'll try to solve these three equations. We have a plus b is equal to 2, b plus c is equal to 1, and a plus c is equal to 0. So now let us try to solve them. How? Let us see. Now let us see, we have, if I put here c is equal to 1 minus b in this, plus 1 minus b is equal to 0, I got a minus b is equal to minus 1, and here I have a plus b is equal to 2. If I sort it out, I got 2a is equal to 1, that is a is equal to half. If a is half, we can put here, we got c is equal to minus half. If c is minus half, b will be 1 plus half, 3 by 2. Okay, so I have this. So now let us try to put these values here so that we can easily find the solution. So now we'll try to see what we have, that is a. A is half. So a is half. So we'll try to put here, we'll have 1 by 2 dx upon x plus 1. B is 3 by 2. We have B is 3 by 2. 3 by 2 x upon x square plus 1 dx. Okay. And plus C. C is minus half. We have dx upon x square plus 1. So now we know that is log of x plus 1 plus. Now what we can do here, if I put x square plus 1 is equal to t, so we have 2x dx is equal to dt, x dx is equal to dt by 2. So it will become 3 by 4 of 1 upon t dt minus half. Here what we can do here, we can directly put the formula for x square plus a square. Okay, so we have the formula here, that is tan inverse x plus c. So now we have 1 upon 2 log of x plus 1 plus 3 upon 4 log of t, that is x square plus 1 minus half tan inverse x plus c. So this is what we have here, that is y is equal to, so I can write here y is equal to this much. So now I have this. So now let us see what we can do here. Now we have given the condition that y is equal to 1 and x is equal to 0. Okay, if I put y is equal to 1, x 0, if I put, I got half of log 1 plus 3 upon 4 x is 0, half of log 1 minus half of tan inverse 0 plus c. So if I say log 1 is 0 and this is also 0, log 1 is 0 and tan inverse 0, if I put tan 0 0, so we will say that for c is equal to 1. So we got c is equal to 1 because all this becomes 0, so c is 1. Now I can put the value here. So I got y is equal to half of log x plus 1 plus 3 upon 4 log of x square plus 1 minus half of tan inverse x plus 1. Okay, so now what else we can do? We can take the LCM here, and I got 1 by 4, 2 log of x plus 1 plus 3 log of x square plus 1 minus half of tan inverse x. plus 1. So now what we can do? Half of log x plus 1 whole square plus log of x square plus 1 whole cube minus half of tan inverse x plus 1. So what I got here it is. So now I got that log a plus log b will be log ab. Okay, so that is how we able to find the general solution of the given differential equation. Okay, now let us try to solve another one. Now let us try to solve the another question. We have just solved 11 questions from the exercise. Let us try to solve the 12th question now. Okay, now let us try to solve the 12th question I have. That is 12th question I have x square minus 1 dy upon dx is equal to 1. We have y is equal to 0 when x is equal to 2. Okay, now let us try to solve this question I have. How we can solve? That is dy is equal to, we have dx upon x square minus 1 we have. Okay, so now how we can solve this? Y is equal to, we can take x minus 1 x plus 1. Okay, so now we have dx is equal to a upon x plus b upon x minus 1 plus c upon x plus 1. So now how we can solve? Let us see. We can put here a x square minus 1. Okay, x square minus 1 plus b, I have x plus 1 plus c, I have x minus 1. Okay, so now let us try to solve this. Now let us try to solve this by comparing. I got ax square minus a plus bx square plus bx plus cx square minus cx, that is. Now I will try to compare a plus b plus c is equal to 0, and we have b minus c is equal to 0 and minus a is equal to 1. Okay, so now what we can do here in a very simple way, let us try to find this value. Now we have a plus b plus c 0, we have minus a is equal to 1, and about this b plus, we have b minus c 0. So now minus a is 1, that is a is equal to minus 1, put here. So I got b plus c is equal to 0 and b minus c is equal to 0. If I add these, I got 2b is equal to 0. That is b is equal to 0. So we have c is also 0. So now try to put this value here. I got dx upon x, because minus 1 plus, what is b? 0. If b is 0, so and c is also 0. So I got this only. So I got y is equal to minus log of x plus c. Now if I put the value, that is x is equal to 2 and y is equal to 0, minus log 2 plus c. So I got c is equal to log 2. Now put this value here. So I got y is equal to minus log of x plus log of 2. So that is how we able to find the general solution for the given differential equation. Okay. Now let us see here, that is I have v is half, so I got d of x minus 1 plus c is also half, so I got dx upon x plus 1. So here I have plus half of log x minus 1 plus half of log x plus 1 plus c. So I have this. So now I got, if I put a value here, that is x is equal to 0, y is equal to, x is equal to 2, sorry. So if I put, so I got plus half of log 1 plus half of log 2 plus 1 log 3 plus c. So I got this value here. So now we have that is minus log of 2 plus, if I take half common, so we got log 1 into log 3. So now I have plus c. So I got this value here is equal to 0. So now if I take, we have minus log 2 plus log 3 power half. Now log a minus log b, I have log 3 half upon 2 plus c. Okay. Now what we can do here, we have c is equal to minus half of log 3 upon 2. Now we can put this value here, so that I got minus log of x plus half of log x minus 1 plus half of log x plus 1. So now we have minus half of log 3 upon 2, y is equal to this one. So that is how we are able to find the general solution for the given differential equation. Now let us try to solve 13th question. Now we have just solved 12 questions from this exercise. Now we'll try to solve the 13th question now. Okay, so now we have the 13th question they have given. That is, the question is, we have cos divided by dx. We have, that is, cos dy upon dx is equal to a. They have given this. Okay, and a belongs to real number and y is equal to 1 when x is equal to 0. Okay, so now let us try to solve this question. Now what we can do, dy upon dx is equal to cos inverse a, or dy is equal to, we have, that is, cos inverse a dx. Now y is equal to cos inverse a into x plus c. So now I can put the value, that is, if I put x is equal to 0, so 0 into this will be 0 and c becomes 1. So now we can put value here, y x cos inverse a plus c. Okay, so that is how we able to find the general solution, to find the general solution for given differential equation. Now let us try to find this. We have 14th question now. Okay, so what is the 14th question I have? That is, dy by dx is equal to y tan x, where y is equal to 1 when x is equal to 0. Okay, so now they have given, what I can do, 1 upon y, dy by dy is equal to 10x dx. Now we know that log y is equal to 10x integration will be sec square x. No sec square x. We know that the differentiation of 10x will be sec square x. Okay. So now we have here 10x. So we can write log of cos x plus c. Okay. Now we'll try to solve, that is log of sec x plus. Also I can write here log of c. So I got log of y is equal to log of sec x into c. So I got y is equal to c into sec x. Now if I put the value here, that is x is equal to 0, cos sec 0 will be 0, cos 0 sec 0 will be 1 upon cos 0, cos 0 is 1. So I got c is equal to 1. So I can put here y is equal to c of sec x plus 1. So that is how we are able to find the general solution of the given differential equation. Now let us try to solve another. We have just solved only 14 questions. Now we'll try to solve the 15th one. Okay. So now let us try to solve the 15th one. Okay. So now we have the question here, that is we need to find the equation of a curve passing through point 0 0, okay, and whose equation is differential equation. We have y dash is equal to e raised power x sin x. Okay, e raised power x sin x, they have given the differential equation and we need to find the equation of a curve passing through the point 0 0. So it means x is equal to 0 and y is equal to 0. So what we can do here, we can write this equation like this. Okay, so after writing this, what we got here, dy is equal to e raised power x sin x dx. So now what we can do, we'll apply here integration by parts. So we have this first function and here we have second function. So ex integration of sin x dx minus dy dx of ex integration of sin x dx. We'll try to find dx. So now I got minus e raised power x cos x minus e raised power x, we have cos x dx, sin x integration minus cos, it will be plus. Now again we'll apply here by parts. So I got, that is ex sin x minus ex sin x dx. So this is I have, okay, so this is I have I. So now what we can do here, this is y, okay, y we have, y is equal to I plus c, this is I plus c. Now I have taken and this is also, so now I will try to put a value here. So I got 2i is equal to, okay, because I have taken this one I. So now I is equal to this much, that was I was doing. Now I plus I, 2i is equal to, if I take what I take common, e raised power x if I take common, so I will be sin x minus cos x we have, okay. So now 2i is equal to this, so what I can do, I is equal to e raised power x sin x minus cos x, here I got 2 because this become I. Now what I can do here, I can put value here this. So I got y is equal to e raised power x upon 2. I have sin x minus cos x plus c. Now if I put x is equal to 0, so I got here e raised power 1 into minus 1, 0 is equal to, sorry, here I got plus c. So therefore c is equal to 1 by 2. So now I have c is equal to half. I can put here Here's the value here I can put. So I have got this equation. Therefore, y is equal to e raised power x upon 2 sin x minus cos x plus half. What I can do? Take 2 as an LCM, and on that side I got e raised power x sin x minus cos x plus 1. So I got 2y minus 1 is equal to e raised power x sin x minus cos x. So finally I found the equation of a curve passing through 0, 0 and whose differential equation is given by this. Okay, so that is how we try to solve this. Now let us try to solve the 16th question. We have 15 questions we have just solved. Now we'll try to solve the 16th one. Now what they have given and what they are asking now, let us see. They are asking about find the equation of a curve. Okay, okay, they have given the differential equation here. They have given the differential equation, that is dy xy divided by dx is equal to x plus 2 and we have y plus 2. Okay, they have given this. Now here we need to find a solution curve passing through point 1 and minus 1. Okay, here we can consider x is 1 and y is minus 1. So let us see how we can able to solve this equation to find a solution. Now see what we can do here, x upon x plus 2, or what I can take y upon y plus 2, we have dy. Okay, and here we can take x plus 2 upon x dx. So now what we can do, we can integrate it. How? Let us see. We put y plus 2 is equal to t, so that no, we'll try to solve in another way. We have y upon y plus 2, okay, and we'll take this here dx. So now let us see how we can solve such kind of questions. Now how to integrate here, easily, x upon x will be 1 plus 2 upon x, like we can integrate here. But now what to do here is we can solve like this, 1 plus 2 dy. Now you can separate it out, dy minus 2 dy upon y plus 2. So now we have x plus 2 upon x we have, so we can write 2 log x plus c. Here what we can do, y minus 2 log y plus 2 is equal to x plus 2 log x. Now if I put the value here, x is 1 and y minus 1, if I put x is equal to 1, okay, and y is minus 1, so we got minus 1 minus 2 log 2 minus 1 is equal to, we have x1 plus 2 log, we have, that is 2 log 1 plus c. We know log 1 is 0, we have 1 here, and log 1 is 0, so it will be 0, 0 we have. So if I add this, we got c is equal to minus 2. Okay, so now I can put the value here. So I got y minus 2 log y plus 2, okay, is equal to x plus 2 log x minus 2. So that's how I find the equation of the solution curve passing through the 1 minus 1, having the differential equation this. Okay, so now let us try to solve the next question. Now we have solved only 16. Okay, so now we'll try to solve the 17th now. So what question they have given? We need to understand this first. We have just solved the 16 questions. No? Now the question says we need to find the equation of a curve passing through the point 0 minus 2, and given that at any point pxy on the curve, the product of the slope of its tangent and y coordinate of the point is equal to the x coordinate. So let pxy be any point. So pxy into y is equal to x. Okay, into y coordinate they are saying that the product of the slope of its tangent, okay, tangent on the curve and y coordinate of the point is equal to x coordinate of the point. So now let us try to solve this. We got dy upon dx into y is equal to x, or y dy is equal to x dx. So now we got y square upon 2 is equal to x square upon 2 plus c. So y square is equal to x square plus c. Now if x is 0, y is minus 2, so therefore c we got 4. So I got my equation, y square is equal to x square plus 4. I put the value of c here. Finally, I got the equation. So now let us try to solve the 18th question. We have just solved only 17 questions. Now we'll try to solve the 18th question. Okay, so now let us try to solve the 18th question I have in my hand. That is, we need to at any point xy of the curve, they are saying that the slope of tangent is twice the slope of the line segment joining the point of contact to the point. So what we need to do? We need to find the equation of the curve given that it passes through minus 2, 1. So they are saying according to the question we have, that is slope of tangent is equal to twice of slope of line segment. Slope of line segment, the slope of line segment pxy joining line segment joining to the point of contact, to the point of contact, that is point minus 4 minus 3. So we can say dy upon dx is equal to 2 into y minus minus 3 upon x minus minus 4. We have this, so we'll have 2 y plus 3 upon x plus 4. We have dy upon dx. So what will happen? Dy upon y plus 3 is equal to dx upon x plus 4. Okay, so we need to find the equation of the curve. Okay, so what we can do here, we'll find log y plus 3 is equal to twice of log x plus 4 plus log of c. Now log of y plus 3 is equal to log of x plus 4 square plus log c. Now log of y plus 3 is equal to log of c into x plus 4 whole square. So we got y plus 3 c into x plus 4 whole square. Now they are saying that they are passing through the equation of the curve that passes to a point. We need to find a equation of that passes minus 2, 1. So if I put x is minus 2, y is 1. So we got 4 is equal to, so therefore c is equal to 1. Okay, so I can put here in this, that is now we can easily put here y plus 3 is equal to x plus 4 whole square. Okay, so that is how we can easily solve the equation. Find the equation of the curve passing to the point minus 2, 1 in which they have given, that is the slope of tangent will be twice of the slope of the line segment joining the point on the xy joining to the point of contact minus 4, minus 3. So that is how we able to solve the numericals. Now let us try to solve the 19th question now. Okay. So now we'll see how we able to solve this question now. So now we have solved only 18 questions. Now we'll try to solve the 19th question. Okay. So let us see what that says. Now let us try to solve the 19th question. What is the question is, that is a volume of spherical balloon there being inflated changes at a constant rate. If its initial radius is 3 units, after 3 seconds it is 6 units. So we need to find the radius of the balloon after 3 seconds. So we can say let x be the radius of balloon after t seconds, and let volume of a balloon changes at constant rate Vk. So now according to the question, dy dt of what is the volume of the balloon, we know 4 by 3 pi a cube. So we will say 4 by 3 pi x cube because we are taking radius as x is equal to k. So now what we got here, if I say this 4 by 3 pi x cube dx upon dt is equal to k. So now 4 by 3, okay, if I differentiate this now, dy dt of this, so I got 3x square dx is equal to k dt. Now we can easily integrate x square dx is equal to k dt. So I got 4 pi into x cube by 3 is equal to kt plus c. Okay, so now I got this equation. Now they are saying if at initial point t is equal to 0, radius was 3 unit. So if I put t is equal to 0, x is equal to 3. So I got 4 pi into 27 upon 3. Okay, is equal to c. So now I got here 108 pi upon 3 is equal to c. So therefore I got c is equal to 36 pi. Now after some time, that is after 6 seconds, they are saying if after t is equal to 6 seconds x becomes 3. Okay, so now we'll try to put this value in this so that we can find the value of k. So it will be 4 pi, we have here, we have taken x equal to 3, t is equal to 0. Okay, so now but after 3 seconds, sorry, radius becomes 6 units. So I will say into 36 upon 3. Okay, 36 upon 3 is equal to k into t was 6 plus 36 pi, 12. 48 pi minus 36 pi is equal to 6k. So I got 8 pi upon 6 is equal to k. Okay, so now I got here not 8 pi, it will be 12 pi. Okay, so now I got 2. So now we got k is equal to 2 pi. Okay, so now I can put the value of k in this equation, that is in first equation 4 pi. Okay, we have 4 pi x cube by 3 is equal to, we have to find the k value, that is 2 pi into t. Now t here I need to take, I take 6. Okay, so now we'll not take the value of t, plus c I have find the value here 36 pi. Okay, so here I got here the c is equal to 36 pi. Now here I need to take that value, that is 6. So what will be the 6 cube? It will be 216 upon 3 is equal to, we have taken the t here 3 plus 36 pi. Okay, so now what I got here, if I solve this, I got 288 upon 3. Okay, because I have just solved this. Okay, 288 pi minus 36 pi, pi is equal to, I have the value 3. So now what I got here, that is pi upon 3 equal to k. So I got here 84 pi. So I got k is equal to 84 pi. Okay, so now putting the value of c and k, that is 4 pi into x cube by 3 is equal to k, we have 84 pi into t plus c I have 36 pi. So now what it will be, if I try to solve this, I got this 4 pi x cube upon 3 I have is equal to 84 pi t plus 36 pi. Okay, so now I can take the common here, 4 pi x cube by 3 is equal to, if I take 4 pi common, I got what here? Okay, no, it will be 1. So 21t plus 9. Okay, so now I got this 21 plus x cube upon 3 is equal to 21 into t plus 9. Okay, so now they are asking, after t seconds they are asking the value. So now what I can do, I find the value of this. Now I find that x cube is equal to 63t plus 27. Therefore x is equal to 63t plus 27 cube root. So finally I able to find the radius of the balloon after t seconds. Okay, I hope it's clear to you now. They are asking about that radius of the balloon, that when its volume changes at a constant rate. So initially the radius was 3 units, but after 3 seconds radius become 6 units. Okay, so it was a spherical balloon. So in this we need to find the radius of a balloon after t seconds. Okay, so Now we'll try to solve the another question. We have just solved 19 questions of this exercise, that is 9.4. So now I will try to solve another question we have. Let us try to solve the last question of this to find the general solution of the given differential equation. So now let us see how we can easily solve. We have dy upon dx is equal to e raised power x, e raised power y. So we have dy upon e raised power y is equal to e raised power x dx. So we got minus y dy is equal to e raised power x plus c, minus is equal to e raised power x plus c. So we have minus e raised power x is equal to c. So I can take minus common. So e raised power x plus e raised power minus y is equal to c. Or I got e raised power x y minus c. So finally I got e raised power x plus e raised power minus y is equal to c, where c is equal to minus c. So that is how we able to find the general solution of the given differential equation. I hope it's clear to everyone. Today we have tried at least 20 numericals from this exercise 9.4. So I hope it's clear to you. If you have any doubt, you can ask, you can comment, you can share my channel also, like my channel. Okay, thank you.